Welcome to ED+U. We're finishing up the Coffee Is series this week, part 5 and part 6. We've gone parts 1 through 4 up to now. Today, coffee is a science. This one's called a science. The next one is called Coffee is an Art. You know, we've all kind of discussed the science and art of coffee and that being part of the draw toward coffee. So we're kind of breaking it up. I think every step involves science and art, right? It's not exclusive to any single part. But in today's class, we're going to look at more of the technical side of kind of the end of the supply chain, and then tomorrow we'll look at more of the artistic side of the end of the supply chain. So, what is science? Let's kind of define what a science is. I love etymology. I love words and kind of getting to their root meaning. Today, science is defined as kind of any system of knowledge concerned with the universe and its phenomena, right? Just any system of knowledge about a thing. And in specialty coffee, we are constantly trying to learn, right? We are constantly trying to gain a deeper knowledge of coffee. There's always something new to learn because specialty coffee in particular is a young industry. This comes from the Latin root scientia, which is knowledge, a knowing, expertness, which is likely related to the verb scindere, which means to separate or distinguish. And again, I like etymology because that's exactly what we do in specialty coffee, right? We are distinguishing what we are experiencing, distinguishing different coffees from one another in order to gain a deeper knowing or expertness about that thing, right? So today, that's kind of what we're looking at. What goes into the distinguishing of different coffees from one another, or the analysis and the knowledge gaining of coffees from one another, right? Welcome everybody else who's just kind of jumped in. Atypica Farm in Puerto Rico, wonderful. And Lee from Germany, welcome in. So again, we're kind of like always trying to discover what makes coffee taste the way it does. Coffee can display itself in an infinite amount of ways. No two cups are ever the same, right? And that's what makes coffee so fascinating to us. We never have the same experience twice. It can mimic all sorts of flavors, and it's because of everything, right? The more and more we investigate, the more we realize we don't know. And so in part 1, we just talked about the plant itself, right? In part 1 of this series, just the genetic expression of that cultivar and the place it's growing changes how it's going to taste. And then there's the human intervention part of farming, right? How that soil is treated, how, you know, the landscape is maintained, different farming systems, different choices made within those farming systems, harvest timing, all that sort of stuff on the farming end, right? That's classes 1 and 2. In class 3, we look at processing and milling, right? So how long between harvest and processing, the processing method and equipment used, how long the fruit is on the seed, right? Microbes that are present and the fermentation that happens throughout the processing, drying time, you know, resting before milling, what kind of milling equipment is used, the timing of all of these things, right? We looked at all these different variables, and these lists, you know, could be so much bigger than I have written out here, right? But parts 1 through 3 is all about what heavily influences the cup on kind of that farm and processing and milling level. Then when it comes to exporting and importing, we're talking about kind of like the environment, the packaging, storage, and all of that can have an influence on how that coffee tastes, right? So now today we talk about having green coffee at hand. We are talking about roasting, we're talking about brewing, and we're talking about our perception of the compounds within coffee. And that's kind of what we're going to frame these next 2 classes around. We're going to be looking at the green coffee compounds, how those transform in the roast, and then how we perceive those when we go to taste coffee, right? So there's an infinite number of variables at play, and that does not change. So we will examine green coffee compounds and physical attributes, how those interact in the roaster, what those compounds turn into, how those interact with the taster, and then how all those things interact with the brewer, right? That's the next 2 classes. So today's objectives, we're going to look at physical characteristics of green coffee, how coffee is green graded, right? That first analysis. We'll look at the compounds present in green coffee, how we perceive those compounds, how humans perceive flavor and what flavor is, and then how coffee is evaluated in cupping up to this point in history. Cool. All right. Let's go ahead and get into it. We might take a break here in a little bit, but again, interrupt me. Let me know if you have questions at any point. Happy to answer them. Thank you for being here. Let's go for it. So, what is green coffee? That's where we're starting at today. We are an importer. We work with green coffee. We just gave a big warehouse tour actually over the weekend. You know, we've got tens of thousands of bags sitting in our warehouse. And within those bags, we have individual seeds, right? Those seeds are processed, right? The fruit has been removed. Those seeds are dried. The moisture content, as we talked about in the previous class, is 12% or lower. They have had the parchment removed in milling. They were bagged. We imported them, and now they are unroasted in their jute bags. And yeah, raw coffee seeds, right? That is green coffee. How is green coffee evaluated? Well, we've got two systems for evaluation. Green grading, which is more visual evaluation, and then cupping. Green grading isn't, I feel like green grading is maybe practiced less and less and less and less over time. We don't green grade every single lot of coffee we get in, but green grading is really important, particularly at the origin level when it comes to preparing to sell a lot of coffee. So we're going to go through the steps of green grading, right? Physical evaluation, and talk about what is important here. But at the same time, the physical attributes of green grading apply to roasting, right? When we go to roast coffee, the physical structure of the seed is deeply important, right? And so going through this green grading, looking at these physical aspects helps us kind of like set the table for the roasting conversation we'll have in the next course. So green grading is a system for evaluating and classifying green coffee based on physical attributes and then natural defects that come about, right? Coffee is an agricultural product. There are going to be flaws. There is never going to be the most perfect lot in the world with zero flaws, perfect seeds that are all uniform. So this is kind of our system for evaluating how many flaws are present and then the other physical attributes of that lot. Green grading is typically done in 350 gram representative samples. So when a lot is, say, received to a mill, they might pool little bits of coffee from as many bags as possible of that entire lot, right? And that's what we call a representative sample, trying to get, you know, not just 350 grams from one bag, one kind of area, right? Different parties green grade for different reasons. And green grading is kind of like done in the kind of like the order of variables we're going to go through. So things that are classified, things that are recorded are screen size, density, moisture content, and the defects that are present, right? So there's kind of a system for basically taking that 350 gram sample and then measuring or sorting out some of these things to kind of get a representation of that final lot, right? So let's talk about screen size first. Screen size is a way of just measuring the physical size of the seeds. Again, within a single bag of coffee, you're going to have a gambit of sizes, right? So screens are kind of what you see here, right? These are little trays and they have these screens. And there are circular holes measured in 1/64th inch increments. So a screen size of 16 is 16 over 64th inch diameter holes. So tons of factors will result in different size seeds, right? For example, Pacamara, a variety that grows super huge seeds. Well, your average screen size in a lot is going to be very, very different than like, you know, a normal Typica plant's seeds. And so you basically put these seeds in the top tray. You might have multiple screen sizes. They're stacked one on top of another. Shake those around, shake them, shake them, shake them. The seeds will fall through and you'll get your distribution of screen sizes that are present, right? This is not something, I'm trying to think how to say this. For many countries, like this chart listed here, there are specifications. So like if a mill receives a lot of coffee, you will measure the screen size distribution, and that will kind of determine what grade of coffee you are dealing with, right? So small, like Central America and Mexico is 14, right? 14 64th inch diameters. Segundas, second, and then superior, these are the best, right? So typically kind of that like 17 to 19 range is kind of considered normal screen size, depending on the country you're in, right? Colombia has Supremo and Excelso. Those are their two grades. Africa, bigger seeds are AA to B to C. And these AA and A are considered the highest quality. So when a mill receives a lot of coffee, they might measure this screen size distribution in order to know how much they need to sort out to achieve a Supremo, for example, or they're just going to say like, this is kind of like what the lot is, right? And can communicate that on. So this might be a precursor to sorting out certain screen sizes and in order to achieve a certain kind of lot. Hopefully that kind of makes sense. But yeah, countries have different specifications. And this kind of helps determine what that coffee is worth, right? When it comes to say like, commodity or, slightly higher levels of coffee. Next thing is density. So density is something we might measure because density kind of tells you about the cellular structure of the seed, right? So mass over volume is density. Great way to think about this is 1 gram of water is about 1 milliliter of space taken up, right? That's why we measure, density is why we can measure pour overs on a gram scale. We know how many milliliters of water we are pouring out, right? So things that are more dense, like a rock, are heavy and compact versus cork, which is kind of large, open cells, right? Very hollow. It's not very dense. So different coffees will have different densities, again, because of everything that preceded the green grading. You can measure it kind of like 2 ways. There's bulk density, where you're just kind of measuring green coffee in a graduated tube. And you will basically divide the mass of that green coffee by the volume it takes up. That gives you bulk density. This is technically an incorrect number. You'll get a value that's less than 1, but coffee is more dense than water, so it means its value should be more than 1 if we're taking true density, which you can measure by liquid displacement. The main thing here is that however you measure density, you do it consistently. So liquid displacement is a way to get true density. You will basically add X amount of water to a graduated cylinder. Then you will add X amount of coffee, and you will see by how much that water is displaced. And so, yeah, measure the mass of the object, measure the initial volume of the liquid, then measure the displaced volume of the liquid. Then you'll calculate the volume of the object by that displacement. So obviously you have to put green coffee in water to do this, not ideal. But that's how you would get true density. I could go through that a little more in depth if you want to, but basically, let's say like a rock has a mass of 520 grams. You've got 1,000 mils of water. When you put that rock into the cylinder, maybe your volume goes up to 1,220 mils. You will then basically subtract that 1,220 from 1,000. That's a 220 milliliter displacement. To get the density, you will then divide the mass of the rock, 520 grams, by that 220 mil displacement, and that is 2.36. That's your density. So if you did it with coffee, you would get 1 point something, most likely. So again, there's a difference between those two, but that tells you basically how compact, how heavy that coffee is. Typically, coffee that is denser has a tighter cellular structure and might have more flavor compounds within it. At origin, before coffee is bagged up, a good way of sorting coffee is on a density table. It's like a tilted, vibrating table, and it might have tons of numbers of teeth, and you'll get different densities kind of rising or falling to different areas and falling off of that table, and they can sort that coffee by density. Things that are super, super light might be like an aborted seed. seed that is maybe half of a shell, or something like that, right? Things that aren't super dense usually have a defect. So that's a good way of grading coffee. Another thing we'll measure, moisture content. We've talked about moisture content already when it came to drying. Optimal content, 9 to 12%, you'll see on average. What that tells you is how much water is within that cellular structure of the seed, right? Some water is very free, right? If you have a sponge full of water and you squeeze it, a lot of free water will fall. Some of that water is more integrated into the structure. That's what we call water activity. So measuring moisture content kind of gives us insight into the state of the water inside. And that's why 9 to 12% is ideal. That's like where microbial growth can't proliferate, but quality won't degrade. 9 to 12% is the sweet spot. Not everybody has a water activity meter. We've been tracking water activity for years in our lab in order to learn more about water activity. But moisture content is a different kind of meter, and it can give you similar information. So that's kind of a moisture content meter. They look very different. I had another picture up. This is water activity. It's a much more expensive piece of equipment. Okay, defects. So this is like the SCA defect poster. And at this point, there's certain kind of like standards for screen size, density, and moisture content that helps a coffee achieve a higher quality status. But then when we get into specialty coffee, we are talking about farming, harvesting, sorting, processing, and milling that is so quality focused that minimal defects make it into the final lot. This looks kind of fuzzy. I thought it'd look higher quality than this. So I might have to check that out after the class. But let's talk about defects just a little bit. Specialty grade coffee must have 0 category 1 defects, which we'll look at on this left panel. And they must have equal to or less than 5 category 2 defects, which we'll talk about. It also says 0 Quakers are allowed. Quakers have been a big topic lately. Quakers are like after you roast a coffee, you get these really light seeds. They're super hollow. They taste maybe like woody, grassy, not very developed. In most publications, going all the way back to the 80s in the first cupping handbook, Quakers have been labeled as immature or underripe seeds that make it into the roast. But there's been some research, and there's actually no correlation from the number of immature seeds found in green coffee to the number found in the final roast. So immature seeds do definitely produce Quakers, but there's something else that produces Quakers as well. Quakers can just happen in the roast. It says 0 Quakers are allowed to be specialty coffee. There's Quakers all the time in specialty coffee that come up in the roast. Often roasters will sort them out. So, by definition, Quakers mean a coffee's not specialty, but that's kind of ridiculous. We drink specialty all the time with Quakers. If you want to read more about this, I highly recommend Rob Hoos has a nice little blog on kind of the history of Quakers and what they might actually be and how to identify them. If you just search Rob Hoos Quakers, I highly recommend reading that little blog, but kind of a tangent. But we are able to say that all Quakers were immature beans, but not all immature beans become Quakers. They happen. Again, it's an agricultural product. So that's kind of our overarching definition of specialty by physical attributes only, right? Not even talking about flavor yet. So again, 350 grams is our sample weight. We usually roast 100 grams. Here's moisture standard, right? 10 to 12%. Here's moisture activity standards, bean size, no more than 5% variance from purchase contracted specs. So there's more methods of classification for specialty coffee based on all the things we've discussed so far. Now, this is where you get into category 1 and category 2. Category 1 are full blacks, full sours, dried cherry pods that make it through, fungus, foreign matter, severe insect damage. This is the number of seeds present in a 350-gram sample that would equal an equivalent defect, right? So it takes 5 insect damaged seeds to equal 1 category 1 defect, if that kind of makes sense here. And again, by SEA standard, one of these occurring in a 350-gram sample means it's not specialty coffee. But that's why we green grade. But if you have a 350-gram sample and you see multiple full blacks, that's an indication that there are many of those in the lot, and that's not going to taste great when you roast it, right? Here's category 2 defects. You can see it requires more of these seeds to equal 1 present defect: partial black, partial sour, parchment, floaters, immatures, withered, shell, broken, chipped, cut, in slight insect damage, whole, husk, right? Those are pictures of those over there. Again, I'm sorry this isn't more high def. It's probably a little bit hard to see, but that's kind of your table of defects, right? So when you green grade coffee, like the first picture I showed you, you are basically laying that 350-gram sample. You're kind of sorting through one by one by one by one and sorting out any defects you find in that 350-gram sample. And you might take multiple passes to sort those out. And then you'll get an idea of like, okay, how many defects are present? You know, does it knock it out of specialty range? Is this actually a problem for this lot of coffee? How much sorting do we need to do maybe post milling, right? Before that coffee's exported or before we're sending samples to a potential buyer? This is a very important thing at the green, or at the kind of like the export level, right? When you're trying to sell coffee. This helps you identify what's going on with the lot that maybe you were just delivered by a farmer. We'll talk about that a little bit more before we move on. So yeah, those are your defect classification. Again, flaws will happen. It's seeing it consistently within a sample that becomes concerning. So why do people green grade? Why are we green grading? Well, sellers of coffee, you know, people at the milling level, exporters, they will green grade for different reasons than a buyer will, right? For sellers, yield factor is really, really, really important. So again, a farmer delivers their coffee to an exporter. That exporter will pull a sample and they will green grade it. And they will basically be able to see from this 350-gram sample, what is the percent loss I can anticipate from milling and sorting this coffee? That tells me the yield factor, right? The weight change from the received coffee to the actual final product that will be sold. That is very, very, very important in terms of knowing how much coffee you have to sell and what price we can sell this coffee for, right? How much work we're going to have to do to sort this coffee, or just knowing how defective that coffee might be and whether it's a specialty lot or not, right? So that's yield factor. There are country specific trade specs, right? This chart is available on our website if you go to the education tab and then green coffee. But different charts or different countries have different specifications for what allows a coffee to even be commodity grade, right? And so color is important with some places. Screen size is very, very important in most places. Defects allowed. The elevation the coffee is grown at might put it into a different grade. So yeah, this is Brazil, Burundi, Colombia. Like every country's commodity market has kind of their own specifications based on their country's coffee, right? And yeah, we can make milling adjustments and determine whether or not a lot is specialty. So that's why sellers green grade. Right, every country's got specs. I can pull that up on our break too and send you the URL if you want to look at that. But for buyers, we might green grade if something just seems off, right? If it feels like there's more defects than expected, or to verify the quality of a sample, or to make adjustments to the roast profile, right? Density has a big impact on roast. Screen size has a big impact on roast. So green grading can kind of give you a little bit more context for what you might want to do with that coffee or what it might be good for. Like I said, green grading is really, really important at kind of a buying level. But after a coffee's been purchased, you know, like I said, after we've purchased a coffee at Imports, we're not going through and green grading every single lot we receive, unless something shows up on the cupping table that's really alarming, and that's very, very, very rare. So those are our physical characteristics, right? You've got an entire lot of coffee. You can learn about the density, the screen size, the moisture content, and the defect count of that coffee. Cool. That's what green grading is good for, physical characteristics. Up next, what's inside the coffee, right? We can get kind of a good profile of the physical characteristics of coffee, but what is actually inside green coffee? How does it transform in the roast, and how does that relate to flavor? This is where I spent most of the time on this class because this is where I feel like a concrete understanding of the compounds that are inside of coffee, the actual composition, the chemical composition of coffee, gives us so much insight into why coffee tastes the way it does, why it transforms the way it does, and how we perceive it, right? And to me, this is the part of coffee that's more important than the physical characteristics. Great, we know the screen size, but what is actually inside of the seed, and how does that relate to the variety, the process, the farm, and the focus on quality, right? Cool. It's 11:30 here. Should we take a break? Let's get through this section here, and then we'll take a break before we kind of get into sensory analysis, if that sounds good. So when trying to kind of organize these green coffee compounds, I wanted to categorize them, and there's multiple ways you could categorize them. But I decided to categorize them based on kind of like what they contribute to the final cup. So here are the categories of compounds. We have organic acids, we have minerals and salts, we have sugars, we have bitter components, and this is a whole mix of things. It's not as specific as sugar, salt, or acid, right? Lots of things in coffee are bitter, so I would lump that all together. Structural components are components that make up the actual seed structure. That's not really related to flavor. But we have textural components, things that contribute to actual mouthfeel or body, and then aromatics, aroma precursors, volatile aromatics fall into here. So these are the compounds in green coffee. Let's dive into each and every one of these sections and kind of learn what is in coffee at the green level, not necessarily the roasted level, but what has this seed developed through ripening fruit, and then what is it maintained or gained in processing, and then what has been preserved in drying and milling, right? Lots of, there's a big journey coffee goes through, and so tons of changes, like tons of like chemical changes are happening in the seed, right? So what do we have by the time maybe we have coffee in hand ready to roast? So let's go through organic acids. By weight, organic acids make up about 5% of green coffee. These by weight percentages are very, 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 very approximate, right? Different varieties are going to have totally different by weight percentages, but around 5% of the seed, right, to give you kind of a sense of scale, is an organic acid. Organic acids are defined as an acid that contains a carbon atom. Very simple organic acids include citric, malic, quinic, acetic, formic. All of these occur in coffee, right? We know these kind of flavor compounds, right? We experience them in other foods. Coffee can produce just about any simple organic acid that any other fruit can, which is really cool. These are small, simple molecules, highly extractable. They contribute to sourness. A lot of them survive the roast. Then there's chlorogenic acids. These are just really complex acid chains, but they're still organic acids. They're just kind of a different subgroup. So caffeic, quinic acid esters, those break down into lots of different things in the roast. Chlorogenic acids are really important in roasting. They create a lot of new things because they are such complex molecular chains. Some chlorogenic acids become super bitter. Some break down into more acidity things, and some break down into more aromatic things, but I lumped them all here. But yeah, you can see the difference in a citric acid molecule versus a neochlorogenic acid molecule, right? That similar structure is present in here, but it has a lot of extra stuff on it. And so it really degrades into different things in the roast. So those are organic acids, right? That's where we get our sourness and our tartness. Next, we've got minerals. Minerals are imbued into the seed because plants need minerals to survive. Everything needs minerals to survive. It's what hydrates us, right? It's why we put hydration sticks in our water. They're full of potassium, magnesium, calcium, sodium, those kinds of things. Minerals are occur in very small amounts, like 1% of a seed, but they survive the roast, and they do contribute like a touch of saltiness to the final cup, right? We've probably all had cups of coffee that are a little salty, and that's kind of the combination of acid and salt together. But mineral salts are compounds where minerals have combined with other elements. So, for example, potassium phosphate, magnesium sulfate. All of these things, again, they survive the roast. And so we get this kind of salty flavor in the final cup because of these minerals that are in the seed. Sugars, a very important one. Sugars make up 8 to 12% of an Arabica seed. The big one is sucrose. There's lots of sucrose in coffee. Sucrose is a bonded glucose and fructose sugar molecule. So in roasting, sucrose tends to break down into glucose and fructose. It is in the seed. Sugars are necessary because they are a huge fuel source for the seed as it is developing a new plant, right? When seeds go to create an entire new plant, they need energy. And sugar is a big part of that. Enzymes in the seed break down that stuff into consumable packages of glucose and fructose. And that's similar to what happens in the roast, as I've already mentioned. These are highly active in caramelization and the Maillard reaction in the roast, right? So sucrose is kind of like a cane sugar level sweetness. Fructose becomes really sweet, more like honey, while glucose becomes a lot less sweet. I'm trying to think, is there anything else here? Yeah, it's germination fuel. And it helps with a lot of other stuff in the plant. Sugar is very necessary in this coffee seed. Bitters, bitter compounds. Caffeine is bitter. It's produced as a natural pesticide within the plant. It survives roasting, it extracts easily. There's actually like a handful of things like trigonelline that is also a natural pesticide that is produced in coffee. Not many plants produce caffeine, though. This is definitely an evolutionary trait. Trigonelline, it is a vitamin B3 plus methyl group compound. It contributes to bitterness. And then again, chlorogenic acids resurface here. They can be very astringent after they've been roasted. So those are kind of our bitter compounds. Aromatic compounds. This is a big group. This is by no means an extensive list, but these are kind of your subgroups: aldehydes and ketones, purines, pyrazines. This is kind of their structure, but they contribute to a lot of different stuff, and they're going to have totally different aroma profiles, right? Aroma precursors occur in the thousands in coffee, and they change, and more are developed in the roast. And this is where we get a huge amount of the flavor notes that we experience in coffee, right? Like what it said, wine has somewhere close to like 300 aroma precursors, while coffee has, 2,000 aroma precursors or something like that. Don't quote me on those exact numbers, but coffee has one of the most complex single ingredients because it can mimic so many different aromas, right? Or it produces so many aromas. So this is a huge group, less than 1% by weight, but a massive, massive group, these esters. And then things that contribute to texture, lipids and oils. And then amino acids and proteins. In the roast, these all kind of maintain a solid form, and then they are hydrophobic, right? They don't dissolve in water, so they are pulled out in their physical form into the final cup, right? We see oils floating on the surface of the coffee in certain brew methods, and so we feel these as a tactile weight, right? Lipids and oils are even more important than sugar as a fuel reserve. There's more calories per gram in lipids than there is in fructose. They are essential for forming cell membranes and then containing moisture for the coffee as well. So the new plant, it consumes this stuff as it's growing. Amino acids and proteins, these are kind of like the building blocks of the seed itself. They create the framework of cells that store nutrients. And these break down and they can create like nuttier flavors, but they also contribute to texture. I'm trying to think if there's anything else that's important to say here. I think that's it. Last, your structural compound, right? So we've kind of talked about how, I'll go back real quick, amino acids, proteins, those kind of help form this structure. These are called cells, right? Cells are these open spaces. And then all of the stuff that tastes good and the plant needs to survive is held within these cells. So the things that actually make up that structure is cellulose, which are glucose chains that are linked together by a straight fiber. Think of it like the rebar of a building that's being created. Hemicellulose is a mixed sugar chain that fills the spaces between cellulose, and then lignin is a polymer of phenolic compounds that coat the cellulose chain, kind of like a sealant. So you've kind of got your rebar, your mortar, and your sealant that kind of creates that entire pocket. All three, it says, are nearly resistant to break down in roasting, right? If they broke down in roasting, we wouldn't have anything in the final product, right? They hold their structure. They're very strong. They don't really do anything to the final brew. They are the structure of the seed. So those are green coffee compounds. But for a quick recap, we've got green grading, physical analysis, right? We're just looking at density, moisture, screen size, and defects. We then investigated a little deeper into like, okay, cool, what's inside of the coffee? Acid, salt, sugars, bitters, aromatic compounds, texture compounds, and then the structure of the seed. So all of these things interact in a roaster. They all matter in roasting. We're not going to go through roasting details today, really. We're going to kind of skip to cupping because, green grading is physical analysis. Cupping is sensory analysis. So we're going to skip over roasting a little bit, and we're going to talk about roasting and brewing in tomorrow's class. So we'll tackle some of that stuff there. But this kind of sets the stage, again, for what we're analyzing when it comes to sensory stuff. But to be able to even taste these things, this green, raw, unroasted seed does have to be roasted, right? So we got to drop it into our sample roaster. Sample roasting is basically roasting with as little intervention as possible. You're roasting pretty light because you don't want to taste any of the roast. You just want to taste what the seed has. So for us, every single sample roast that we do, basically every coffee is dropped into the same temperature drum. We don't mess with any airflow or any fuel throughout the roast. We just let the coffee go, and then we get the coffee out of the roaster at a certain amount of time or a certain amount of development after first crack. And it's very little development. We're going to talk about those variables tomorrow, but all this to say is as little intervention as possible. We want our sample roast to be repeatable, right? When we're talking about analysis, we are wanting to do something that we can do the same way every single time, right? As few changing variables as possible. So sample roasting is a standardized light roast of around 100 grams. 100 grams is about standard. Some people might do 150, 200. Some people might do 50 because there's more and more roasters nowadays that can do different amounts. But yeah, 50 to 150, 100 grams is your standard size. So like this kind of like old school, more old school roaster, this is what you used to see in all the sensory labs, and you still see them very commonly. These do 100 grams. This is what we used to roast on in our lab. We now use these roasts where you get tons of data. You can track all the data points of the coffee. But yeah, again, the idea is minimal adjustment so you can repeat the profile over and over and get a good read on like what is actually going on inside of this coffee, right? There's an Akawa. These do 50 grams. Yeah, this is an air roaster, so a different kind. Yeah, lots of different roasters nowadays. But again, we're going to kind of skip over roasting and get to cupping. After sample roasting, we are cupping the coffee. This is our good friend Scott in our sensory lab. All these people are from our sensory lab. Sensory is a huge part of what we do as importers, and it's for a different reason maybe than many roasters, right? So just like green grading, different people have different reasons and therefore will follow different protocols based on their needs, right? Cupping for us, we cup, offers, which are basically coffee we have not bought, but people are trying to sell us. So there's offers that we'll cup in our sensory labs, and our green buyers are cupping it. Then if we buy a coffee, we will cup a pre-ship sample, right? So after all the coffee's been milled, we get a sample before it's exported and we cup that. Then we cup it upon arrival, and then we will cup coffees I think every 2 or 3 months that it sits in our warehouse. As long as the coffee is there, it's still in our inventory, we will continue to cup it. So we cup a lot, right? And for us, it's about describing what that coffee is like, and basically being able to accurately then give that description to a roaster, so a roaster kind of knows what they're dealing with, and then roasters can taste it. So there's cupping for buying. There's cupping for seeing how a coffee is changing in storage, or how a coffee changed, pre and post milling or pre and post shipment. And then there's, cupping for creating a roast, right? For developing a coffee, figuring out like, how do I actually want to roast this coffee to make it its best potential version, right? Or even cupping brews, actual pour overs on bar, maybe, right? There's lots of different reasons. For us, and for most of the industry, cupping, established by the Q grading system, which we've talked about before. Step one, you're weighing out your sample, right? It's a certain coffee to water ratio. We cup in little Gibraltar cups instead of like those larger cupping bowls. So we weigh out 9 grams of coffee instead of 13, which is more common. You fill that cup to the brim, right? With your 205 water. You start the timer as soon as you do that. You extract the coffee for 4 minutes, 4-minute brew time. Then you kind of like stir across the surface, right? You break that crust that has formed at 4 minutes. The grounds kind of sink. At that point, the water is cool enough to where the coffee is no longer really extracting. And then you will clean off any of that, frothiness and residual grounds off the top of the cup surface. Allow that coffee to cool. You want it at least below 140 so you're not burning your mouth. And then you're tasting that coffee and evaluating it through whatever system of evaluation you follow. And that's what we're going to talk about next. Sensory analysis. This has been a hot topic, right? We have a new Q grading system. It's officially happened. We have the CVA, a new sensory form that kind of like breaks the legacy cupping form we've used since 1984. Sensory analysis is different from cupping. We'll say that right there. Sensory analysis is a scientific discipline that's been used for years and years and years and years, right, to figure out what do consumers like. That's kind of sensory analysis. And there's lots of different tests in sensory analysis, but we do call cupping, a scientific discipline. And that's where coffee is a science. So we're going to kind of talk about like how coffee's sensory analysis has changed over the years, what's wrong with it, what's right with it, what works, what doesn't work, and how we can all use cupping and change how we cup to achieve the goal that we are trying to set out to do, right? We all cup for different reasons. How do we best achieve that goal? So sensory analysis is a discipline used to evoke, to measure, to analyze, and interpret reactions to food, beverage, whatever. And in many disciplines, it's all about sight, smell, touch, taste, and hearing, right? The entire environment affects our perception of a product. Some industries are far more concerned with environmental things. So everything impacts the human senses, obviously, right? Just in the moment where we are, eliminating our psychology from it, sound, touch, appearance, and texture all impact flavor. And flavor itself is made up of taste, aroma, and trigeminal sensors. So different kinds of tests, sensory tests, or purposes of those tests may change variables to one or all of the above for the sake of market research, understanding a buyer trend, market preferences in different regions, right? Like you'll have different test subjects. But yeah, sound emission has an impact on how we perceive things. How something feels, before we've even tasted it affects its flavor. Appearance is a massive thing, right? If we see what it looks like, that informs our expectation of what it will taste like, right? Stronger color, we expect a stronger flavor. And then, yeah, you've got taste, aroma, and then trigeminal, which is kind of like, like, I don't know how you would, what's the word I'm thinking of here? Trigeminal sensors are for things that are more like we would think of it as like bad or maybe poisonous. I'm trying to, what's the word? I'm like over here, a trigeminal nerve. Yeah, can't remember what kind of stuff falls into trigeminal. It's like bad stuff, basically. There's bad tastes, obviously, bad aromas, but these things kind of all inform flavor, right? All this leads to flavor. In coffee, we're not super concerned with appearance, sound, or touch, right? We're not recording that stuff in a cupping. We're also not always, doing things entirely to our environment to make our environment the same no matter where we are, right? We cup in different rooms in different countries across the board. We try to make it, we try not to play music. We try not to, we're not cooking eggs in the corner of a cupping. We're not like, trying to change the atmosphere or affect the sensory experience, but we also aren't recording those kinds of things either, right? We are concerned with texture, trigeminal, aroma, taste, and all how that contributes to flavor, right? It's purely the experience right in front of our face or inside of our face, right? So let's talk about flavor a little bit because we've defined sensory analysis. Let's define flavor. Flavor is the sensation produced by, perceiving something in the mouth by the senses of taste, smell, the general tactile experience, temperature receptors in our mouth, right? Our mouth is a touch organ. We can feel the weight of it, and then we have taste and smell interacting with us as well, right? Flavor is the sum of all of these characteristics. So you can break flavor out into taste, aroma, body. Let's define the three of these real quick. Taste is chemical. So, when we talk about the compounds in coffee, acids, salts, sugars, and bitters, that kind of whole right side of the chart, those are tastes. Chemical, those are molecules, and we perceive those on our palate, right? Sweet, sour, salty, bitter, and savory are the big five tastes, right? So it's not about apple, pineapple, chocolate, nuts, right? It's purely sweet, sour, salty, bitter. We all perceive these things because we all have papillae on our tongue that detect these things, right? Our taste buds. Each bud on our tongue contains 200 to 1,000 receptor cells. Each cell within a taste bud is usually devoted to one kind of taste. Soury things, salty things, sweet things, bitter things, umami things, right? So there's no like zones of our tongue necessarily, but different taste buds might have a higher concentration of certain kinds of cells. So taste, purely a palate thing, sweet, sour, salty, bitter, umami. Then we've got smell or aroma. This one is the primary driver of why we experience flavor notes, right? Like taste is a very small percentage of the entire flavor experience. Aroma is where most of the experience comes from. And it's because aroma hits straight to the brain. It is things we are smelling, you know, outside of our nose or inside of our mouth. It goes straight into our olfactory system, which is linked into our brain, right? We are literally taking in particles into our olfactory system, and that information hits the olfactory bulb, and gets passed into the limbic system, where that information is immediately decoded. And the more we taste or the more we smell something, the stronger that smell is coded into our brain, the easier it is to recall that smell, right? The more familiar we become with it. Um, so, olfactory neurons pass this information straight to our brain after those compounds are basically trapped or captured in our olfactory bulb. It's kind of like putting a key into the lock, and all of a sudden it fires on that olfactory neuron. And it's linked again to our limbic system. Our limbic system is responsible for emotions, behaviors, memory, right? Smell is deeply, deeply, deeply important to survival. It's the only way animals know where to go, where to avoid, what food's good, how to do things, who their family is, right? And it's the same thing with us. It's deeply ingrained in our survival. I think this quote kind of like, encapsulates why smell is so important. Olfaction closely couples to other functions like gestation, right? Taking something in our mouth, taste, and also involuntary memory formation, right? We know smell brings up memory in a very strong way. From an evolutionary standpoint, sense of smell is critical for evaluating safety, assessing danger, and recognizing social relationships, right? If we didn't have smell, a lot of our life would be really, really difficult. So aroma is deeply important, and aroma is a huge part of what makes coffee what it is. And then last is tactile or body. So pressure, traction, temperature can play into this. But in coffee, we think about weight and texture, right? How heavy that coffee feels, but also just the actual tactile experience of it, right? Something more rough versus something soft, something round, silky, syrupy, smooth, creamy, right? All those kinds of words. So again, taste, aroma, body. Taste is the chemical reaction, sweet, sour, salty, bitter. Body is the physical interaction on our touch organ. And then aroma is the whole kind of brain perception interaction with smell, right? All of this informs flavor. So those things, like if I were to go back to this real quick, like aroma particularly is kind of like deeply personal. All of us have had unique experiences throughout our life. But also there's also like errors that can happen when we're tasting things over and over. This is something I never heard about in coffee, but it's very, very, very important in sensory analysis. There are physiological and psychological sensory errors that we are all susceptible to because we're human. In sensory analysis, setting up a test that limits these errors is extremely important. And I think these are great to look at for coffee professionals, because then you can start to detect them when they're happening in a cupping and control for them. We have a whole series of blogs our head of sensory, Ian, has written on this, but there's a lot of errors. Adaptation, right? The more and more sweet things you taste, the less and less sweet we start to perceive things, right? You've had so much sweet on your palate that things start to taste less sweet than they actually are. Or having a lot of sweet things and then all of a sudden having something bitter makes that bitter thing seem way more bitter than it actually is, right? Salt enhances our perception of sweetness. It suppresses the perception of sour, right? So you think about a cupping table, how often do we encounter these kinds of errors? If we taste natural, 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 natural washed, that washed is not going to taste very sweet after you've had a bunch of naturals. And those naturals will also maybe tone one another down. Or the opposite will happen. those naturals will tone each other down, and that washed will stick out as something super special because it's way different than everything that's preceded it, right? So the diet, 100%. What you've eaten before cupping, very important. And that kind of links over to psychological errors, right? So psychological is more about expectations and perception and less about, how sugar, salt, and acid interacts on our palate. So information given with a sample may trigger preconceived ideas. Any information in a cupping we know about a coffee informs how we expect that coffee to taste. If you know something's a natural, well, you're going to expect it to taste fruity, right? And you're probably going to write some fruity notes down on your cupping form, even if it's not the fruitiest natural you've ever had, right? Like just knowing that forms a lot of expectation. And that's really important in flavor. We'll kind of address that in a second. Logical error, when two or more characteristics of the samples are associated in the minds of assessors, right? So if you can see the seeds, the roasted coffee, and we know that large beans are typically less acidic than small, if we can see the coffee, that's too much information. We are already expecting something, right? Stimulus error, cupping the top 10. You expect it to be amazing, so you probably score it more amazing than you would otherwise. So there's lots of psychological errors. There's a whole another group here. Pattern effect. Let's see here. I'm echoing a little bit. There we go. Building flights from mild to intense is a problem. You don't want to do that. So what we're seeing here is that if you know anything, if there's patterns or like some sort of like non-random setup, it can heavily impact how you score something or how you interpret something. Going back to your comment, Jera, if I pronounced your name correctly, time error, positional bias. One's attitude undergoes subtle changes over a series of tests, right? So if you're hungry, if you're fatigued or indifferent, you're going to score it differently, right? So this is something that we have thought about a lot in our cupping experience, right? In our sensory lab, we don't want to be biased. We want to know that, cool, if I come in on Monday and I write orange on my cupping sheet, I am going to assign it the same amount of value as I will on Thursday when I come and encounter that kind of similar orange, but I'm in a totally different mood, right? So mood, everything affects how we value things. In coffee, this is really important because all of this deeply personal stuff can affect how we are interpreting what we are presented. And in coffee, the presentation or the flavor of something deeply impacts the price, and that price deeply impacts somebody's livelihood. And this has always been the challenge of specialty coffee, right? Something that is so subjective as flavor can have such a strong bearing on how much money somebody makes in a year. And so who is assigning meaning? Who is saying what is specialty? Who is saying what is high quality? Who's participating in that dialogue? How are people calibrated, right? All of that sort of stuff is really, really important. So again, flavor is an integrated perceptual experience. If you were to kind of give it a scientific quick term, that results from gustatory, olfactory, and trigeminal stimuli with aroma or that olfactory sense being the dominant contributor. So it's about perception, right? The more we know about it, the more meaning we've assigned to it, the more neuronal firing that happens, the more we expect something, the more we'll actually taste that thing, right? Perception, it's a proactive process. And so the experience of flavor is heavily built up in our brains, right? Because it's linked to aroma. We all have unique histories and perceptions. And so we can never really understand how somebody is perceiving something compared to us, right? People spend years working in the same company, becoming more and more calibrated over time as their experiences and expectations become more calibrated. But that's where the question is like, for us at least, how do we evoke, measure, analyze, and interpret something that's inherently subjective, right? How can we make this a more objective test? That's really, really important, right? So how we test, how we cup determines how valid the data we are getting out of that cupping is, right? So these are components of a sensory test. We're kind of back in that sensory analysis world, the scientific discipline, and we're trying to relate it to cupping. It all stems from the objective. What are we trying to learn? What are we trying to do with this test, right? That will inform the kind of test we're carrying out, who is going to participate, and what we should do to the environment that this is occurring, right? The objective is very important in sensory analysis. That tells you how to carry out the entire test. Then you can collect that data from that test. You can know it's reliable, and that can give you good information, right? The problem with coffee is oftentimes we have multiple objectives. We want to describe the experience of the coffee, but we also want to score the experience. That's two totally different things, two totally different objectives that should require two different kinds of tests, right? So different kinds of tests. We have objective or analytical. We have subjective or hedonic. Objective tests are simply asking, what is this product like? I'm trying to figure out, what does this taste like? Typically panels of small groups of trained tasters, people who are trained to describe a product. Subjective tests are, the main question is, do people like this product? I'm not trying to learn what the product tastes like. I'm trying to find out, do you like it? Panels here are typically large numbers of untrained consumers, right? The consumer you're trying to sell to. So we kind of see there's already a disconnect here. In coffee, we want to do both, but they're totally, totally different forms of testing when we're in a sensory analysis world, right? So there's those objective tests. Examples are discrimination. Triangulation is an objective test. Two coffees are the same, one coffee is different. Taste those three samples and try and find the one that's different, right? We are learning about the coffee. A descriptive test. We are describing properties and their perceived intensity, right? So somebody just saying, okay, the acidity is intense or medium intense or low intense. That is somebody describing a coffee. When we get into liking, ranking, scoring a coffee, then we are no longer learning really about the coffee. We are learning about the taster, right? We are discovering whether somebody likes it or not. That is subjective, right? That's what we talked about. Typically, this is for testing consumers and if somebody likes a product. But this is what we do in COE cuppings. It's what we do in the older SCA cupping form, right? So we're not really learning about the coffee when we're saying 8.25. We're learning about what the taster thinks about a coffee, right? So again, these are two different tests. Cupping is admittedly both tests at once, and it always has been, right? Ted Lingle, the Coffee Cupper's Handbook in 1984, said cupping is a method used to systematically evaluate the aroma, taste, and texture characteristics of a sample of beans. That's objective. We're just evaluating or describing. But in SCA, a new system to assess coffee value, this is their newest definition of cupping. It is a method for the sensory assessment of coffee, which involves tasting several cups per sample, using a different set of coffee beans for each cup, which is ground and brewed independently. The purpose of a cupping may be to do a descriptive assessment, objective, an effective assessment, subjective, or both combined. Here's a paper. Misuse of sensory tests can occur when more than one sensory test objective is combined in a single test. For a long time, coffee has been doing two modes of thinking at one time, and bias can come into play very, very heavily when we're doing that. So all that to say again is that cupping isn't sensory analysis. Cupping is not a science. What we are trying to do is basically create a quality test where anybody who's tasting are highly trained and knowledgeable of their product, right? This goes back to coffee is like a discipline where we want to learn more. Everybody who cups, everybody in the industry, we want to learn more about coffee. So I'm not saying that cupping is bad, but we do need to recognize that oftentimes we are doing two tests at once, and that's not necessarily scientific, right? And so it becomes very difficult to assign value, right, when our bias is coming into play. We started to recognize this, and that's why we have completely changed how we cup at Cafe Imports. And I'm not here to say you should do it how we do it, but I like making people aware of these things because we can start to control for bias a little better, and we can start to communicate between buyer and seller a little bit better too as well. So we are doing quality testing in coffee. We are not doing subjective or objective. We are doing quality testing because we're trying to do both. The CVA admittedly does that. The new form broke out subjective and objective tests into two different sheets of paper, but the taster is still doing both at once, right? So they tried to make it look like sensory science, but it's not sensory science. None of what coffee has done has ever been sensory science, right? And that poses problems. But what has cupping in these forms been good for? Asking questions, asking what a coffee tastes like, and giving us a format to talk about it, right? Creating a language. We've created an entire language in how we describe coffee, aroma, acidity, sweetness, bitterness, aftertaste, flavor, balance, like all of these words that we've used forever. We created a language with these forms, right? They're great training tools. There are better training tools out there when you focus on one thing at a time. And then we've used them for comparison, right? Maybe comparison to ourselves, comparison to one another, figuring out how to calibrate with one another, right? They're not all bad. We've created an entire language around coffee with these things, but coffee recognizes its shortcomings, and that's why it will probably continue to evolve. It's why the SCA evolved it. It's why it's going to continue to evolve into the future, right? I think at the end of the day, we all want to better assign value and communicate value to people with totally different experiences other than ourselves, for sure. So we made the coffee rows for our own cupping. Like I said, we saw these problems. We wanted to make our cupping objective. We don't want our sensory team going in one day and saying peach equals 8.5, and then the next day saying peach equals 9.25. We want to say that peach every day, no matter our mood, equals the same score, period. And we can show you that if you are a producer, a seller, a customer, whoever you are, right? So we have tried to basically eliminate as much error as possible. And this is a program that is free to use. So if you don't like the CVA, or if you want to try something new, I highly recommend trying this out. It's free to use. It's our cupping form. It's basically a flavor wheel that you tap on. It gets bigger and bigger and expands and becomes more and more specific as you continue going from fruity to berry, tropical. You get more categories until you're very specific, right? So specificity. The more specific of an input, the greater impact on score. Notes at the same specificity level are weighted uniquely, meaning different flavor notes are weighted differently in the scoring engine, whether it's a washed, natural, or honey, and what we expect from that coffee, right? So expectations are considered. And then intensity. For every flavor note you input, you have to select an intensity. The intensity is always in reference to a flat 80. Every single cupping we do at Cafe Imports, we have what we call a flat 80. It's basically a washed Central American 80-point coffee, right? And then we taste everything else next to it, and able to have a reference point, right? Reference points are really important to limit bias and errors. So the whole idea here is our cuppers are just describing things on this virtual rows or this virtual flavor wheel. They're just selecting what they taste and the intensity. That's all our cuppers do. They clear the table, but the back end, the scoring engine, basically creates that descriptor string and then scores that coffee for you. So we do not score coffee in our lab. We have a scoring engine that handles that. That we worked a long time to kind of figure out like how weighted should every single hundreds of flavor notes be based on its process. So this is where it's like people are starting to think of new ways. I can't take any credit for this. People are thinking of new ways to basically score coffee, right? And be able to communicate value. You can't communicate your expectations, but you can communicate a spreadsheet of values assigned to flavor descriptors, right? So that was our goal with this. I don't want this to be a huge plug, but if you want to mess with this, you can make an account in our portal and then you have it. You create flights and keep going. But what I do want to leave you with here is some basic rules for making a good cupping test. So after learning from sensory analysis practices and different tests that are out there, these are the basic rules we have for cupping that I would give to you. Rule number one, what's your objective? Are you trying to compare coffees to one another? Are you trying to simply describe the cup, or are you scoring? Try and only do one of those things at a time. If you're going to score, you don't really need to write down flavor notes. Try and focus on the scoring, and put notes down if you're feeling it, but don't try to describe as intensely as possible and then go back and score. It's two modes of thinking, and one of them will not perform as high of a level. But define your objective. Is this for buying? Is it for feedback? Is it for profiling? Is it for putting on bar, right? Eliminate the unnecessary stuff and just focus on what your objective is. 2, do everything consistently. Obviously, this is huge, but we are creating a test in order to eliminate variance and bias. Taste everything you can in the same place with the same equipment, the same way every single time, right? Do everything the same as possible. Throwing up an important cupping on the fly where you know what everything is and you're using unfamiliar things, like that's not very valid data. If it's something that's deeply important, like somebody else's livelihood, do everything consistently. Taste as blind as possible. This is huge. And this is for even if it's espresso and you're trying to figure out an espresso recipe, or if it's, buying multiple lots of coffee, you need to randomize your samples, have them on a random order on the table, use a randomizer app, or a spreadsheet or something, randomize your samples, have somebody randomize it for you, have somebody else set up that tastings, and you should not know what's on the table. If it's coffees, maybe that, you're trying to decide if you want to buy them or not, put them on the table with other coffees and randomize it. Coffees you already have, coffees you're not buying, right? The more you put it amongst other stuff, the better your data. This isn't something we often take the time to do. But yeah, and if you're tasting, something on your brew bar in your cafe, have somebody prepare the different kinds and then A/B it, right? A/Bing is a very objective test. It's not subjective at all if you don't know anything. Use a reference if possible. It's not always possible to have a flat 80 like we do, but I never did this before working at Cafe Imports. And now every time I cup, I put a baseline coffee on the table before everything else, and it resets my palate and it helps me reestablish, okay, what is baseline specialty? Therefore, how much more intense or how much more sweet or how much more fruity or how much longer of an aftertaste does this nice coffee have, right? We are always able to reset our expectations. Expectations inform flavor. If you don't have an 80 point, if you're not going to keep, an Excelso Colombia or, a large regional Mexico lot, use your house blend. You know that coffee. You love that coffee. Use your house blend, set your bar there, and then cup against that. Anchor and reference your experience to something you do know is really important for cupping. Not many people do that, but it's a big one. And then taste everything more than once. Replicate tests to validate your data is another really important one. What this means is for us, let's say every day our sensory lab has 4 flights of 10 coffees each. That's 40 coffees. They taste 5 days a week. And let's say they have to cup through 120 different samples that week. Those coffees are going to appear on tables throughout the week more than once. It gets you more notes, more scores, more data, more descriptions, more everything to help you really know, like, where is this coffee amongst all the other coffees, right? Replicating tests is another great way to make it more objective. Those are our rules for cupping. So some of this sounds like hard work, but again, I think we are working in an industry that wants to be more transparent, and transparent means everybody should know how everybody's kind of tasting and valuing things, right? And so just knowing, I highly recommend reading through all those sensory errors and see like, oh, this definitely comes up in our cupping protocol. And finding a way to kind of eliminate those sensory errors is a great start for making your own test, right? You don't need to cup 5 of every coffee. What does that tell you? Is that part of your objective? We cup 1 cup of every coffee and then we replicate it throughout the week, right? Now, if you're trying to taste for defects in one lot, then maybe you do need to cup, 5 cups of one offer. But those are very different objectives, right? We don't write down aromas. We don't really care what coffee smells like. We care what coffee tastes like, right? If you don't need to do it, eliminate it from your protocol, right? There's no best way to cup. That's why it keeps changing. It's good to kind of look at what sensory analysis has always done, the science, the discipline of it, and see what we can apply to our own cuppings in our own labs or on our own bars. So in review, let's see, I have some questions here. So far, the best part, a 5. Thank you, Samuel. I really appreciate that. Glad you like this one. And then Lee, with regards to the sample roasting, we'll discuss that more tomorrow for sure. Like I said earlier, with sample roasting, we are setting our roaster to the same charge temp every single coffee. And then we are not adjusting power, fuel, or airflow throughout the roast. The coffee just rides on the temperature it's at. And then we have a certain percentage of development after first crack that every coffee reaches and then drops. So we will talk about that more tomorrow. But you can't make every coffee experience the same temperature in the same amount of time, right? So it's more about same charge temp, same development percentage for every coffee with no adjustment in between. On our old roaster, like the old small Probats, we did 1 airflow change. And we actually have a video of that on YouTube, like that process. So depending on what roaster you're obviously working on, you'll find your own kind of protocol that seems to work. But yeah, we try and not touch anything. And then very minimal development, very light. Okay, so in review, we talked about physical, density, screen size, moisture, defect. We talked about chemical, acid, salt, sugar, bitter. We talked about aroma precursors. We talked about textural, and then we talked about the structure of the seed. All of this will be deeply important with roasting and brewing tomorrow. But we kind of skipped over some of that stuff, right? We kept it to the science, so we moved on to sensory analysis, right? So how do these compounds transform in roasting? And then how do they extract in brewing? That's what we're going through tomorrow. Today, we looked at how do we evaluate the physical and then evaluate those compounds in terms of tasting, right? How does flavor work? To me, that is all kind of more science related. Physiology, psychology, and then compounds interacting with all that. That was kind of the goal of today. Tomorrow we get into the art of it, right? What happens when we manipulate the roast? How do those compounds react or develop or break down or change? And then how do we extract coffee? How does water, remove those compounds? But what can we change to kind of, make new or different flavor experiences, right? That is the art of coffee tomorrow. And then there is the art, of course, of service. That is the last thing for many of us, or just the art of drinking and enjoying coffee and kind of what that means to us, right? Everything we've discussed in every class is kind of culminating to that point, right? The beauty of enjoying that kind of singular, one of a kind experience.